Hey, good morning or afternoon, everybody. My name is Jim Tyrrell. I'm a principal solutions architect at Red Hat. Thank you so much for joining my talk about 10 design tips for microservices developers. This is a talk I've been delivering quite a few times over the last couple of months, and I'm really excited to give it to you today. Just a little bit of background about myself. I am a 25, 27 year now Java veteran. I started in the mid 90s when Java 1 first landed. I spent almost a decade and change as somebody that's very passionate about user experience. And if I'm honest with myself, it really has been there since the beginning of all of my being, right? I'm a very empathetic person to the plight of us poor humans in the world around us. Finishing up about 8 years ago, I earned a Master's of Design Methods degree from the hardest design school, at least here in North America. I went weekends to the Institute of Design in Chicago. In that design school, it's not necessarily colors, art, layout, and fonts. It's design, strategy, innovation, leadership, behavioral economics, and really what makes us tick as people. And that's something that I bring to bear on this software development thing. And I have spent countless years, countless late nights debating, talking about, thinking about the intersection of humans and technology and what brings those things along. If we were live in a room, I'd ask you to raise your hands, and if you had ever heard of Don Norman, inevitably a few people might have heard of Don Norman. If you don't know Don Norman, you at least know a term he invented at Apple in the early 90s, named and by the name of user experience. You also might have heard of Norman doors, right? These doors that are at the mall or at a hotel where I sit right now, where you're not really sure whether you should push or pull that door. He's been a long time speaker and writer around human experience. Clive Thompson is an absolute brilliant writer, writing for Wired Magazine, among other places, but wrote this book called Coders. Coders is a fantastic book, but the thing that really hit me in the middle of that is that us software developers are making what I call design decisions, at least in the context of my master's degree, all the time, day in and day out. And we aren't necessarily thinking about the needs of the humans and what it is we're trying to do for them. And finally, the last book I'd want to bring forward is Alan Cooper's book. Again, you might not know Alan, but you certainly know what he worked on in the late 90s, early 2000s. We know that as VB, .NET, and some of the WYSIWYG code editing platforms on a Microsoft in that time period. I take a lot of inspiration from all three of these writers, and I'm trying to bring some of the thoughts that they've had in these books forward in this talk as we work our way forward. So one of the things that this talk was kind of a lead up to is this idea of the microservices Death Star. You know, this is a picture that you have maybe seen in the past, right? All these different microservices are coming together. The challenge is, though, that you as a human aren't necessarily always capable of seeing what it is that you are seeing. And by me just suggesting that this is the microservices Death Star of Facebook, Twitter, and the write up and lead up to this talk being that you are predisposed, if you will, to kind of confirming that that is what you were looking at. So we are definitely drawn to details that confirm our own beliefs. This codec is almost 200 some behavioral economic biases that impact us day in and day out. And they are something that you should at least be thinking a little bit about as you're writing software. So this talk promised us to at least think about the Netflix and Twitter 500 microservices Death Stars. You know, there's some things in these pictures that you just can't escape. The fact that you need to wire various methods together, various functions, endpoints, whatnot, wire those together in modern microservices architecture. That is both a blessing and a curse. One of the things I would ask you to think about, though, is that it isn't just the communication between these well-exposed endpoints. In modern object-oriented programming, the stuff I've been doing for 20 plus years in Java and a little bit of C++ at the beginning, but as we've been practicing in object-oriented programming for going on now 6 decades, we have notions of public getters and setters, public methods that cross all these boundaries of all those little lines that are back behind that endpoint, represented by each of these directed graphs or lines. And that, I think, leads to some challenges when we're doing typical microservices deployment and some challenges there. And I'm going to hypothesize a methodology to think about how we write object-oriented programming. So the first thing I'm going to talk about here is this idea of a very quick object-oriented primer. If we go back to almost, 26, 27 years ago at the beginning of Java, we had this notion of a Java bean. Right, a Java bean was a no argument constructor. private member variables, and a bunch of public getters and setters. This has been standard in almost all my object-oriented training, both in university and then after the fact. Almost all examples do this. And my one polite ask is I would hope that we would have done a better job of having a two-string method in most of these objects. I'm amazed how many GitHub projects in Java I look at don't have a two-string method. Maybe don't even have a good test coverage to give you an idea about what it is you should be doing with that class. With all that, one of the headaches that we get with the typical monolith is the interconnectivity that's going on with this. And, there are with public classes, and let's hypothesize that we have 10 classes. If they could, all communicate to each other, you might have 45 different paths of communication from one to all the other communication channels that might exist without any ordering, right? Just me talking to you, talking to our friend, talking to our friend. If we have 10 of those in a room, there's 45 channels of communication, right? Very quickly, that blows up on us. One of the reasons we did service-oriented architecture, more than a decade ago. Certainly some of the needs for messaging-oriented middleware and or messaging in general, things like Kafka, etc. But what happens when we think a little bit about this example? What happens if there's 5 methods in all these classes that can be talked to, right? So instead of these 45 communication paths, depending on the order of operations, you could have, in this case, 1,200 some paths of potentiality of what you're doing inside of a thing. I get this is a little bit theoretical, and this is probably not necessarily realistic, but it also doesn't say that there's only one correct path, or there's only one path of communication that's possible in your code either, right? There is some gap between one path and this 1,200 plus path that represents the things that people might do. But the mathematics of being able to test all these things blows up on you very, very quickly. And then if you get to the point of the traveling salesman, if you're a computer science programmer by training, you certainly get that programming model, if you will. And that might lead to a 50 factorial or 10 to the 64th number of possible paths that exist in your code base. Said in other words, or maybe another way, you as a human are 10 to the 17th number of atoms. The universe is, we think, 10 to the 72nd or so. In other words, with just a few classes, with just a few methods, the amount of surface area that you might need to test or evaluate is nearly infinite when measured against the 1, 2, maybe 10 correct paths that you're intending for end users to use. And it is in this mathematics of bloat, if you will, that we get to some pretty heady problems. And I would even go so far to say that, if you just have 10 classes that are invoking in any order, it's a 10 factorial problem or 3.6 million. If only one path of execution is correct, what is that? 2/100,000th of your choices are correct. It's certainly not on the level of winning the lottery or getting eaten by a shark or any number of bad things that can befall you. But that's only with 10 classes. How many of you have a code base that's only has 10 classes in it, right? Most of us are dealing with classes numbering in the hundreds, maybe even the thousands in our monolith. This creates a lot of headache for us. And I would argue, even if you're doing microservices architecture, we'll talk about that in a second, you still have some of this bloat because of the notion of public classes with public getters and setters that can be instantiated from anywhere within your ecosystem. So let's talk a little bit more about these Death Stars and some of the things that are going on with this. That it isn't just these endpoints that are exposed or these well-read, well-tested things. In this land of microservices, it's every line around this circle. Every line around this circle might represent 10, 20, 50 other points of communication that can be invoked and created within your objects. And that creates a lot of headache and really prevents you from being able to test accurately everything that you are delivering within this. So going on a little bit further, I think this is one of our grand challenges. So whether you're doing Java development, and some of these examples use Quarkus. In any case, whatever you're doing, there's a lot of stuff that you can be doing within this, I think, to slow down the blast radius of what it is you're looking at. And my first thing is let's get rid of any public getters and setters, and let's talk a little bit about where we're going with that. But first, 2 other books. One is this idea of domain-driven design. I think this is a really great way to think about our software development. So rather than having various folders that we'll get to in a second, we deal with the use cases at hand. A user, a hotel room, a TV, a movie, a hotel booking, a treatment, whatever. Those are the nouns, if you will, that you're working around in your code base. The last book that I'll mention in this talk, Switch, is a great book. One of the things that I really like about being able to do behavioral change in the context of that book is this notion of tweaking the environment, basically ensuring through guardrails that there is no way for the user to fail. And if you think about what we can do as software developers, our canvas is nearly infinite and bottomless. And it's this lack of guardrails that creates a lot of headache and mayhem for us. So I assume at a J4K conference, a lot of us are Java developers. We have been doing what is depicted on the screen forever. We have, com.companyname.controller, domain, repository, service, model, view, controller, who knows, any number of packages and folders that map to our classes. Inevitably, these folders have hundreds of files in them. And in a really worst case, all of them have user.java in them, which really slows down our ability to do wayfinding or figuring out where it is we are within our code base, right? So we've done this forever, and that is most certainly a bit of a headache and something to think a little bit more about. As we are going forward, one of the things that I think about in our modern web services world, at least with Quarkus and Java, Spring Boot, et cetera, we want to have something on the front end, an API that speaks JSON typically. In the case of this write-up, model is the annotated Java class that speaks JSON and is marshaled and unmarshaled for us by the runtime. Persistence is an object that has annotations on it that helps us deal with this idea of what's written to the database, auto number fields, names, etc. And then service is the code that writes that persistent object to the database. But this has some of that same problem of every class having somewhat of the same name. If we have all these in or if we have these same names represented in multiple different packages, like that aforementioned user example, you really get to a point of not necessarily knowing where you should go. So as you're looking at your code, I would really suggest that in this hypothesized model of development, we would have API user, model user, persistence, and service users. That way it's pretty easy to know where we are, and we don't have to figure out for the package name, which might be very hidden in our IDE, what it is we're looking at, what it is we're dealing with, and just have a full map of where we are going. So one of the things that I've talked a little bit about is these public and getter setters and just all the lines of communication between all these microservices. In Java, this is a very typical use case, right? We have a public class, a private member variable, and various getters and setters of public. They are very easy to create those getters and setters with right clicks in our IDEs. But you know what? From a human perspective, we are having to parse a lot of words, trying to look at a lot of different stuff within this. And I would say that this public keyword creates a lot of chaos against the mathematics of the bloat of the possible communication paths in whatever it is we're delivering. So rather than having public, private, and public getters and setters, public classes, private member variables, and then public getters and setters, I would suggest that we might consider getting rid of that public keyword on our class, but then also getting rid of the modifiers on our member variables. And in this case, essentially this model user object is just a placeholder or a data encapsulator, if you will, to just hold on to the data that we have within our marshaled and unmarshaled object. We no longer have to worry about getters and setters. If we want to refactor first name and make it lowercase, I know as Java coders, it probably drives us nuts. But if you have React View or other developers in your ecosystem of people you hang out with, they probably like first name as lowercase n. But if you're refactoring this, you don't necessarily have to update those member or the getters and setter not member variables, but methods rather, and don't have to necessarily remember that. I would also say that these private keywords on these member variables are a little bit problematic. So you get to the right-hand side of this example, we're basically just using this idea of an empty modifier or possibly protected, slows down the blast radius of what's available from this object throughout your code base. And this facilitates us keeping nice, tight things that are well tested, that you don't necessarily create dependencies in other microservices across your code base. The compiler, if you will, enforces a JVM enforced firewall at the package level across all these objects. And what I'm really saying, what I think happens here is that the package really becomes your object, that the notions of a lot of examples in this space conflate the annotations around what's written to the database, what isn't written to the database, what is or isn't written to your JSON object that's being marshaled and demarshalled by your runtime, And then the code base that's writing things to the database and things that are speaking web services are all very different domains, very different modalities of thinking, and have different constraints on you, the developer. And doesn't it make sense to break these four cases up within your package, limit how far abreast they are able to be invoked by others, such that the only, in this case, entry point is that JSON speaking endpoint, giving you great segmentation and modularization across the code base. So this is something I've been talking about for a couple months now. This is almost a year-long journey of me exploring this with others. And this is just something that I've come up with that really helps me encapsulate, and in the spirit of the best parts of Unix from way back when, give yourself the ability to have these really tight endpoints, these really tight classes or groups of classes that work together to solve the heavy lifting problem of your of the code you're trying to deliver. So a few more things to get us to our 10 tips. I'm always amazed that a two-string object isn't on most classes. I would absolutely almost require in this programming model that the middle two classes, model user and persistence user, absolutely have to have a two-string on that. I often like writing software to writing a book, right? It has a beginning, middle, and end. And the terminal in front of you gives you the output of that book as you're running through your test cases, as you're authoring and writing that software. And a two-string method, and especially for these two objects, is an easy way to see what's going on. And you know what? Unlike the getter and setter methods that are a quick and easy way, I would argue that they create a lot of bloat and some overhead and maintenance that's a little bit of a headache. In the context of two-string, right, it is so easy to just do a right-click on our IDE, output that two-string method, and have that available for us. As we think about tips 6 and 7, that API user endpoint has some things for us to think about and things I want you to think about. And these tips aren't just unique to Spring Boot, Quarkus, Java development in general. I think if you are writing JSON speaking endpoints, these are tips and tricks you should always be thinking about. You should be thinking a little bit about the HTTP response code. Are you returning, 200, 400s, 500s based on what's going on there? Are you returning good human readable string messages to give your end users a chance to figure out what's going on? Do you want to indicate failures? Do you want to indicate what's going sideways? One of the examples I talk about is people are passing in first name as a capital N, but you expect a lowercase n. Do you give them help to let them know that that's what's going on proactively? Or do you expect them to just kind of guess or figure that out? And the other one that I think is an absolute atrocious thing in this world is a white screen of death. I'm of the opinion if you hit any endpoint with at least something that feels correct, you should never, ever, ever, ever return a white screen of death. You should always give people a little bit of a fighting chance to submit or to show them what they should be submitting in that response. Even if they didn't give you anything that you could accurately return any data, say that you're only have 100 users in your system and you return an ID of 105 from an auto number field and there's nothing there. Rather than a white screen of death, you probably should just return an empty set of strings and let them know that nothing is there. And I get that the current libraries around this don't exactly do a great job of this, but as somebody that's tried to consume these services over the years, it is really, really problematic. The other thing I would say is that as you are writing these web services, remember your end users, your end user consumers, more than likely are not seeing the terminal where you've created these. They might not even have the ability to ever go look at that. So the only way to communicate with those users is through the URL that you've previously given to them and giving them the ability to look or play with that. Some other things to think about in this is this idea of a health check, right? A method that returns some sort of idea that not only is the thing up and running from a JVM perspective, but is the backend database available? Has it been handling traffic? Have you been putting things in the message queue? Have you been taking things off the message queue? Just something to give you some sanity that, yeah, indeed, the service is running and we expect it to work well. By the same token, if people hit an endpoint and the database isn't available, should they get a null pointer exception or should they get a nice curated message that says the database isn't available right now? And I get that creates some translation and other challenges for across the planet, but it's certainly better than giving people a white screen of death and no information. Another one that has driven me crazy over the years is this idea or the lack therein of a build date or version number or the last pull from Git or something that just lets me know what the version is of the currently running code in microservices. Another one I like to think about is a get usage method, right? In more than a few organizations, people talk about the documentation that they're writing to give people the idea of all the endpoints and the various JSON speaking web services that are available to them. I don't know how you can keep your code base and that documentation in sync. I would much rather have the code and or the interaction of the code document itself as to how people are using that. We'll get to that in tip number 8. And it's amazing to me that we don't always give people easy, quick to read documentation from the endpoints themselves about how you might invoke this. How do you invoke function A, B, and C that gets strung together to do some heavy lifting? That's a typical use case for your end users. Just something to think about as you're working along around this. Another one that I like to do, and I've seen some code bloat around this, is that people have and this is a very specific example, the Quarkus. And it works in a lot of other things, right? So this is a simple post method. We're having a JSON object, in this case, a model user passed in. And what I generally like to do is that I pass in and return the exact same object. This, in a lot of ways, prevents that white screen of death and gives me the opportunity to be able to document, if you will, or self-document the web service that I'm deploying in a way that allows me to just get the same data back that I'm putting in. And that aforementioned example of first name with a lowercase n, and I then have a uppercase n for whatever reason, returning it with a different object, it's pretty easy for me if I do all this in one marshaled object that gets hydrated and dehydrated as it's going in and out of my method. I can basically self-document that I expect first name to be an uppercase n in the input as because it's being implied by the output. This is the way to self-document your code and get you going in or keep you on track with what it is your developer is doing, but it also prevents that white screen of death problem that I spoke to earlier. Another one to think about is testing. And for all intents and purposes, the middle classes, model and persistence, test user in this case, are basically just holder classes, right? They are just records, if you will, that are holding data that's being set by the runtimes and some other helper classes that exist within this. And through the API test user and the service test user, I don't have test on there, we can exercise basically all the various execution paths through these 4 classes within this package to facilitate being able to go up and down through the stack. And very purposeful, I chose these letters, API, model, persistence, and servers, so they stack top to bottom or maybe left to right in your mind as to the JSON speaking endpoint is the entryway, reading left to right. You go through the JSON object to the annotations of what's going in the database to the thing that writes to the database and then back again. So that's what I was doing with that. But within testing, it's pretty easy to facilitate that. Another tip around testing is this idea to ensure that there's no nulls passed around. I'm not going to name in a recording, but a certain worldwide airline, I was looking at putting some tickets on it, and they had null, comma, null around the city code I was looking at. We really should work pretty hard in our web services to ensure that we are presetting any of our string values, at least in Java, and other work around other variables to ensure that nulls aren't passed around. While nulls as a string are very easily put into a database, they are somewhat problematic because is a null empty? Is a null actually what the user put in? You really are just better off having an empty string and not trying to overload the keyword null, meaning 2 things. It's either empty or it was null. It's just really, really problematic and really something that you should look for and probably have some test cases around to ensure that when you instantiate these classes that there are no nulls floating around within that. The other thing to think about is some telemetry. The micrometer project is a simple, easy way with some simple annotations to inject, in this case, a simple counter that basically gives you a counter about how many times you invoke this. Through various other monitoring packages, you can export that data automatically, do some reporting on it, be able to gather information on it, look at what's going over time. Telemetry like this is maybe the next step up from a health check. And it just gives you a good feeling that things are running well and that things are behaving as you expect them to be. So I've presented these 10 thoughts to you. I've got some future things as we kind of come into a conclusion here and some Q&A at the other side of this. Some of the things I've been thinking about in this is thinking a little bit more about Java records and what does that mean around immutable data objects that are passed in and passed back out. I definitely think that is something I'd like to explore a little bit more. In the second and fourth position, so the fourth position, Vertex Event Bus for a Majestic monolith and local development. And I think interfaces and public APIs, in this case, company name.api, that we need to think a little bit more about common enumerations, common message formats on a common local JVM bus that allows us to communicate maybe across a code base with something that's documented and consistent across what it is you're passing around. Do you want to have a user that can go across various parts of your system? I think this also might facilitate or help a little bit with maybe not necessarily type safety for JSON objects with compile time checking, but it could allow you to use the same Java definition in multiple parts across your code base such that everybody's speaking the same kind of JSON object, if that makes sense. So just something to think about, something to have in the back of your mind. Another one with this style of development, right? This idea of these microservices broken up by package with the JVM enforcing a firewall. You now potentially give yourself the opportunity with Knative or Lambdas and Amazon to independently, completely independently deploy, stand up, take down, redeploy individual microservices with no cross-pollination from any other group of packages, because the JVM is enforcing this idea that everything is in a bucket. Now I get that this common API thing at the top might blow that up a little bit, but that, something I want to think about and explore a little bit more. But think about the headaches of hand jamming deployments and what does that mean to you, the software developer, and what can you do to facilitate making your life a little bit easier for your operations people and also your testers. Another one to think about is splicing in workloads for testing. How do you do dark deployments of your APIs within a fabric of services that are running? How do you automatically grab data off of the production workload and maybe slam that into your development or test cases? Maybe going the other direction, how do you inject your code into the workflow of a production system, taking production data, but the actual production return is just in a local copy that you're dealing with? You're actually not returning the service updated data to the production instance. It's split off with, again, another dark pattern there. I think there's some things to explore there and some things I might want to check out within that. And then, of course, the last one I want to speak to in this list is just what does it mean to do test coverage and reporting on it? How are you ensuring that you have all of the methods invoked and checked and that you have complete code invocation and complete code coverage with what it is you're delivering? So with that, we're pretty much ready to take any questions if anybody has any. And it looks like there's a few things in this. Before that, I get to these questions. If you would, feel free to reach out to me on LinkedIn. I'm known as the designer tick in social media circles. I don't quite yet have code examples of this out on GitHub. I really need to get that done. My wife's out of town this weekend. Hopefully I can get to that soon. And so anyway, it looks like the first question is, so let me read that out loud. I think the most common case is a REST interface between two applications not facing the user directly. And often you don't want to disclose information to the outside in case of misusage. And man, that is lacking a little bit of context. That's more of a statement than a question. So yeah, so I'm going to inject some thoughts on this one, right? So you are, and I see this, and I have thought a little bit about this. So a couple things. One is most RESTful endpoints are not going to be exposed publicly to the internet. They are going to be behind some sort of password protection, bearer token, or some other way to secure them. If that is indeed the case, letting people know what the input and outputs are of your interfaces, I think is just at best security by obscurity, which is never a good thing. And you really should be thinking about being a good steward of the security of your system and ensuring that the inputs and outputs of your RESTful web services do not otherwise harm or damage your system. And I get in these RESTful services, we don't necessarily have the SQL injection faults that we had and other things, but we certainly could have other problems that go along, whether we put too much data and blow up the database, whether we're not doing some sort of metering about how often things are being invoked, whether people hack the system. And I was just reading an article yesterday about some of the new video games that are coming out. There's a huge, and who knew this, that there's a huge ecosystem of hackers that sell breakages for games that come out so people can basically have unlimited lives, right? And I think to just pretend that by not publishing the RESTful endpoint data going in and then having that match the data coming out, you're just hoping to be, dare I say, a little bit sloppy in what you're doing and not necessarily have to think about all the ramifications of what it is you're doing and protecting the end users from themselves. So yeah, I get two things are going to talk to each other, but at the end of the day, there's going to be security. You need to think defensively and a whole host of other things as a developer that you're just not protecting yourself by not publishing a schema that people might be able to get their hands on. And man, in this day and age with network sniffers and everything else, to think that people can't figure out what the inputs and outputs are of your web services, you're probably really not thinking enough through the real problems that you have, which are actually the business problems and ensuring people are doing good things with your applications. Are there any other questions from the question fairy? Seems like not. No. All right. So with that, I thank everybody for their time and attention this afternoon. Please reach out to me at LinkedIn if you'd like a copy of these slides. Soon, some of this code will be out on GitHub to check out. And if you have any future comments, any thoughts on this, if you want to call BS on this topic and this idea of the package becoming the object, I would love to talk to you. With that, good afternoon, good evening, good night. My name is Jim Tyrrell. Thank you so much for your time.